Algebra 2, Chapter 8, Section 4, Graphing Rational Functions. So in the last section, we talked about a reciprocal function where it had a constant over a variable or some polynomial in the denominator, linear, right? So that was reciprocal. A rational function is pretty similar, except instead of just having a constant in the numerator, it can be any polynomial. And then the denominator can be any polynomial as well. It could even be a nonlinear one. So the idea is, as long as the polynomial in the denominator isn't zero, and it's just a fraction like that, you got yourself a rational function. Now, it is really important when you're doing this to find the horizontal and vertical asymptotes. It built a lot of structure into where the spacing is on the coordinate plane and makes graphing so much easier. So, first thing, for the vertical asymptotes, it's whenever that denominator's function is zero. We've been doing that this whole time. It's just now there might be more zeros because it can be higher degree polynomials. The tricky one is the horizontal asymptotes. The most you're ever going to have is 1. But that means you could have 0. So you could have 0 or 1. All right? And the 3 bullet points below this here, this describes when you have horizontal asymptotes. So if the degree of the numerator is greater than the degree of the denominator, like an x to the 5th over x squared, there is no horizontal asymptote. Okay. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. So if the degree of x is less than the degree of, so we have, what do we have here? How about x over x to the 5th? Yeah. So no horizontal. Y equals 0. If their degrees are the same, so like an x cubed over an x cubed, the degree, it's the ratio of the leading coefficients. So like make this a 3 and a 5 here so we can see it. So the asymptotes would be 3/5. It's just the ratio of the leading coefficients. All right, and that's when they match. So that's the breakdown of the 3 scenarios, very simplified out. And let's say you had something with a horizontal asymptote and 2 vertical ones. You're basically setting up the coordinate plane into 6 regions, right? The nice thing is you only need to find the 3 domains there and and plug in values for those 3 domains. And the reason for that is, well, it's a function. So if you're looking in this to the negative infinity part of the graph here, it's either going to be above or below the horizontal asymptote. That's all there is. All right. You may notice something interesting about the no horizontal asymptote example they give you. There is no horizontal asymptote here, and sometimes there just isn't. Sometimes there's another, we call it a slant asymptote. You'll learn about those later this section. let's go to a problem though. But these, I'm gonna highlight them in blue here. These 3 bullet points are pretty important. All right. So example 1, graph with no horizontal asymptote. And I can tell that because the degree of the numerator is 3 and the degree of the denominator is 1. That means the degree of the numerator is larger. So what do I have to do? I'm going to find the vertical asymptote by taking the denominator and setting it equal to 0. And that would be x equals 1. So basically, what I have is a coordinate plane. And I am interested in the left and right hand side of that line, x equals 1. So let's make a table of values. X and f of x. Oh, let's start it over at -3, -2, -1, 0. And I can't be at 1, but let's try 0.5. Let's see what that does. There's my asymptote at x equals x equals +1. So now I'm going to go let's do 1/2 beyond +1 there. And 2, 3, 4, 5. Yeah, that's a lot of points to plug in your calculator, but I mean, this function isn't too tough here. You can type that in. So we have -3 to the 3rd power over -3 minus 1, or 27, sorry, -27 over -4, which is going to be, oh shoot, what's that? 6.25? No, 6.75. All right, so there's 1 point. So now I'm just going to use my calculator to figure out the rest of the table values real quick. Crap. This is always the boring part, right? And right now you don't even get to watch my face because I got my camera turned off. Watching Willie type in stuff into his calculator. But I feel like if I were to just tell you what the whole table of values was, you would miss out on something. Because right now you should be typing in the calculator at the same time that I am. Yeah. Yep. Okay. I got it working. All right. So now we go -2 and -2, and we get 2.66. -1, -1, 0.5. 0, 0, 0. What about 0.5 though? Negative 0.25. All right, off to the other side of the asymptote. -6.75. Oops, hold on, that's not right. Oh, I guess it is. And now it's 2, get yourself an 8. And my bet is this next one might be starting to get a little bit too big. 13.5. Yeah, I'm not even going to be able to graph that anymore. So let's see what we get. Now, one thing that happens when we do this is we'll discover that we don't quite have enough information. So -3 is up at 6.75. 1, 2, 3, 4, 5, 6, 7, 5. -2 is at 2.66. -1 is at 0.5. 0 is at 0. And 0.5 is at -0.5. So you can see here, looks like I'm just running straight towards the graph, but I can't be. I'm either going to have to go down or I'm going to have to go up at some point because I have to run along that asymptote. So I'm going to need to find another table of value point to put in there, probably 0.75 or 0.9 or something like that. Something really close to 1 to see if it goes up or to see if it goes down. 1.5 is -1, 2, 3, 4, 5, 6.75. Here we've got, +8 for 2. That goes way up there. 1, 2, 3, 4, 5, 6, 7, 8. 3 was 13.5. 9, 10, 11, 12, 13.5. Okay, so this one on the right hand side, my guess here is does one of these things. Though I kind of want to check this point, so I'm going to type it back in and see if I got the right value here. Yep, I do. Okay. So now this graph comes down in here, but it's got to go either up or down. So all I'm going to do is type in, how about 0.9? Oops. Oops. I typed in the wrong numbers. Hold on a second. Typed in 0.09 for one of them. There we go. And if I plug in 0.9, I get -729. So that's down. So now I know my graph goes down. And that's all I needed to know. Because there's no horizontal asymptote, you can see that from the right-hand side, it just kind of goes up. So we got this weird shape here. It's coming down, and the other one's kind of coming out. That's the shape that's happening. Pretty neat. But all it takes is a big table of values and making sure that you know the directions of everything. Like originally when I first did this problem a couple years ago, I thought it was going to turn up like this and be shaped kind of like that. But then I plugged in some more numbers closer to the asymptote and I found out it goes down.